Why are your most expensive engineers still babysitting AI models that can't execute beyond a single prompt? Corporations burn over $200 billion annually on salaries for repetitive, information processing tasks. The gap between single-turn AI outputs and true automation is massive. How do we actually capture that trillion-dollar efficiency shift? The answer isn't writing better prompts. Prompt engineering expects a static output. Agent engineering means architecting an autonomous system that makes decisions, plans, and takes action. We are moving from a paradigm of direct human instruction to the agentic loop. Instead of passively waiting for your command, a true engineered agent continuously perceives its environment, deliberates on its internal goals, and autonomously acts on your systems. Compare the approaches. A traditional model generates a snippet of code and stops. An agentic system generates code, runs the test suite, reads the failure logs, and patches its own bugs. This requires a fundamental architectural shift. Agents need memory. While a basic chatbot relies entirely on its current context window, an engineered agent reads short-term conversational context and queries a vector database for long-term historical specifications before acting. Next is tool use, or function calling. The old way meant a human copying text into another app. The new way? The agent dynamically invokes your backend APIs. Then comes goal decomposition. You no longer feed an AI step-by-step instructions. You hand it a high-level objective like deploying a feature, and it autonomously breaks that down into building images, pushing to registries, and monitoring deployment health. This is autonomous software development in practice. The system reviews the initial pull request, maps the dependency tree, and orchestrates the entire continuous integration pipeline without manual oversight. But what happens when something fails? Traditional AI gives up or hallucinates. An engineered agent uses reflection and self-correction. It evaluates the resulting error message against its intended goal, figures out why the fix failed, and devises a new strategy. One developer types a prompt. The other deploys a system that debates with itself until the solution compiles. The output quality isn't even in the same league. To tackle massive complexity, you engineer multi-agent systems. You don't build one massive AI. You spin up a researcher agent to find data, a writer agent to draft, and an editor agent to critique, all communicating autonomously. Think of it like hiring a specialized executive assistant to organize a corporate retreat. They don't just book a flight. They negotiate venue prices, manage dietary restrictions, and troubleshoot delays dynamically. Making this work requires an orchestration layer. Frameworks like LangChain or LlamaIndex provide the scaffolding to stitch together your LLMs, vector stores, custom API tools, and planning modules into a cohesive, goal-directed workflow that doesn't crash. In supply chain optimization, these orchestrated agents monitor global shipping routes and demand forecasts simultaneously. When a port backs up, they dynamically reroute orders to minimize costs. In IT operations, an agent proactively monitors system logs. Instead of merely alerting a human at 3 in the morning, it diagnoses the anomaly, executes remediation scripts, and only escalates novel, highly complex issues. The same architecture parses thousands of legal contracts. It flags compliance risks and drafts custom amendments based on precedent, replacing armies of junior analysts manually scrolling documents. The stakes for 2027 are existential. Organizations clinging to the old way will be locked into generic, off-the-shelf SaaS platforms. They will face strict limitations on what their AI can touch, resulting in walled gardens and disjointed workflows. Meanwhile, competitors engineering bespoke agents will deploy autonomous systems that tackle multi-step problems faster, cheaper, and perfectly integrated into their proprietary data structures. They will simply outscale you. But you can't just let AI run wild. Agent engineering mandates strict guardrails and safety mechanisms. A customer support agent needs hard-coded filters preventing it from accessing payment records, no matter how convincingly a user prompts it. And here is the reality check. Poorly engineered agents fall into infinite loops. If your self-correction logic is flawed, the agent will burn through thousands of API credits doing exactly nothing. This is how you capture that trillion-dollar market shift we mentioned earlier. You stop treating AI as a conversational tool and start treating it as a raw software component. The future belongs to those who write the orchestration logic that automates entire departments, not individual keystrokes. By 2027, prompting will be a baseline expectation. The defining, highly compensated technical skill will be architecting robust, multi-agent frameworks capable of executing days-long tasks with zero hand-holding. You have a choice. Keep hoping the next generation of base models magically solves your specific business logic, or learn to wire these primitives together into a custom cognitive engine you actually control. Don't just talk to the AI. Build the environment it operates in, hand it the tools, and engineer the agent that builds your future. Ready to upgrade from prompt engineering to building real autonomous systems? Subscribe to learn how to orchestrate your own agents.